I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this March 2026 lecture series, we are discussing about pressure, displacement and temperature transducers. Today, we are going to discuss about potentiometric transducers in biomedical transducers and sensors. First, why do we need this topic? We need an accurate measurement of physiological parameters for proper diagnosis and monitoring, which is helpful for patients, clinicians, and industry persons. For patients, they need a precise diagnosis and continuous monitoring, and clinicians need reliable data for treatment decisions. And industry, they develop a medical device with accuracy. See, the solution, we need a solution for invasive techniques, lack of precision, high cost and continuous monitoring, patient comfort, miniaturization and wireless capability. We need a proper device for improvising continuous monitoring and patient comfort. Our main aim is this. First, what is a potentiometric transducer? Here, the displacement to voltage conversion through variable resistance takes place. Displacement to voltage conversion through variable resistance. Here, the main thing is a resistive element, wiper contact, a voltage source and output terminals. Here, the wiper slides along a resistive track and output voltage changes proportionally. It measures displacement accurately. The concept is displacement to voltage conversion through variable resistance. That is our concept. See, types of potentiometric transducers. We have linear motion and angular motion, and the applications involved here are linear motion. It measures displacement directly. Straight resistive track with sliding wiper contact. Angular motion, circular resistive track with rotating wiper contact. See the diagram. Angular motion, it measures the rotation or angle. Applications for linear motion, joint angle and limb movement. Here the application involves joint flexion and prosthetics control. The advantages are simple, reliable and cost effective. See, here we are using signal conditioning for potentiometric transducers. First one, potentiometric output. Second, which is fed into voltage divider, a circuit, then amplifier stage, then filter. After filter, we have ADC, analog to digital conversion, then microcontroller for processing the output. First thing, we need to extract the output, the sensed output. The sensor which takes the environmental signal and which converts our environmental signal into a proper electrical signal. With the help of transducer, we can get that signal. Sensor sends the information, transducer convert that information into measurable electric output, electric pulses. Here we are using potentiometer as a transducer. This transducer output is fed into voltage divider, then amplification, filter, ADC and microcontroller. See the performance characteristics, output voltage versus displacement and ideal versus actual response. See the diagram. Here the applications of potentiometric transducers in biomedical, blood pressure measurement, respiratory monitoring and joint angle measurements. See the design considerations. Here we need to consider biocompatibility, sterilization, patient safety and size and form factors. See, we need an accurate, non-invasive measurements with patient comfort and safety as top priorities. First thing, how do we integrate our design thinking concept with this potentiometric transducers? First one, empathy is our patient needs, and defined part, we need to incorporate our patient problem statement with our defined part, and ideate, we have to map our technical concepts in ideate part. See, here I've included a student activity, think, pair, share, designing a potentiometric transducer. In this transducer part, first one, we need to choose an application, identify the parameters and select potentiometer type. First, select one biomedical measurement scenario, identify the parameters, list key physiological quantities to measure and select potentiometer type like a linear or rotatory or or based on the application, either we choose linear or rotary, and then justify your choice. See the diagram here. I've included blood pressure, respiration, joint angle, and heart rate. Then assessment questions. Here we have 3 questions. One is from GATE and Industry Metronic 2023, and conceptual question. First one is the output voltage of potentiometric transducer with the 10 volt supply and 5 kilo ohm resistance of 6 volt. What is the displacement? Second, see the answer. Output voltage ratio 0.6, displacement 0.6, and displacement 0.6 into full scale. Industry question: why are linear potentiometers preferred over rotative ones for chest wall displacement monitoring? The answer is direct measurement of linear movement simpler, and signal conditioning better accuracy for smaller displacements. Conceptual question: explain how potentiometric transducers convert displacement to voltage. The answer is wiper slides on resistive track and resistance varies with position, and voltage divider principle applied for accurate monitoring. See the summary part. First, we have discussed the working principle of potentiometric transducers, and then design, signal conditioning part, types, performance, and final applications. Applications in biomedical industries and biomedical field. Here I've included some of the reference for our topic. Definitely it will help you to get clear understanding about the topic. Thank you all.